Hey, everybody, welcome to episode 9 of the Taps and Patience podcast. I am here with my co-host, Harrison of Precision Ingenuity, and I am AJ of Design the Everything. And I feel like I'm starting to sound like a radio broadcaster now. Like I have that intro dialed.
As the more we do this, the more comfortable we get. Eventually, it's just going to become like just a normal reaction on the start of these things. So it's becoming that normal radio voice.
Someday I'm going to stop saying and during the podcast too. Though we've gotten better at that.
We have, and that's good. Do you have a good week?
I mean, life-wise, yes. Machining-wise, no.
Uh-oh. What's going on?
So I made a classic mistake, and I knew better. With these carabiners, I was kind of just running them. And because I was working on other things, I was just keeping the machine running, and I wasn't doing any post-processing on them. And I was not doing I was not doing a good job at quality control, which naturally came back to bite me, and now I have a bunch of bad carabiners.
Oh no! How many bad ones you got?
I have been too afraid to count.
Okay, that's
probably at least a dozen or two.
Well, out of how many carabiners you're going to be doing, that's not too bad. And this is the thing with production runs. If you haven't done a lot, is production runs show your weakness whenever you start running massive amounts of parts.
Yes.
It's real easy to stand in front of a machine, stay focused, and get pretty good parts most of the time. It's much harder to feed a machine consistently, have a simple setup process, and get parts out that are consistent. That's a lot harder.
Yep. I was able to keep the machine running. So I was making bad parts, but I was making good parts too. And in the last 5 days, I ran the machine for, not including today and yesterday, because I stopped production as soon as I realized I had an issue. But in the 5 days before that, I had the machine running for probably 70 hours total in 5 days.
That's super impressive.
So I mean, it helps when your shop is in your backyard and you have a 2-hour cycle time, because then you can just walk out to your shop, switch pallets, walk back inside, and you can get up in the morning, run one right away, and then right before bed, you can come out and run one at 10. So it's not hard to keep the machine running for 12, 14 hours, 16 hours.
Yeah. Yeah. That's the hardest thing about me is my shop's about 10, 15 minutes away. So I can't just do that.
Yeah.
So question, what have you learned anything since you figured out that you're doing bad parts, and what was the main cause if you did figure it out?
So we'll start with the main cause. So I'm getting these blanks laser cut from SendCut Send. And if you are watching the video version of the podcast, which I think is only available on Spotify, they look like this. I learned a couple things. One, for whatever reason, the carabiners in this batch are even smaller than the ones in the last batch. They're undersized from SendCut Send. And I don't know why. The last batch was also undersized, but not as undersized. I don't remember the nominal. I think it was 190 wide on these, 190 thou. And these ones are reading 170 or less.
So sorry,
go on.
Oh, I was going to say, so in my experience with laser cut parts, because I used to do that a lot, granted, we didn't really check our stuff super consistent, but different manufacturers of materials cut differently, and your machine will typically have a kerf setting, and if they are changing suppliers, or even if it's just batch to batch, it can affect it. And for what you're doing, relying on that laser cut edge, that's probably even the speed at which they cut it. There's so many things that can affect that kind of stuff.
The other interesting thing, and this kind of, I think, indicates of their problem, these ones are the correct thickness from what I order from SendCut Send. The other ones were about 20 thou oversized, in thickness. which is fine. It doesn't really change that much other than like I need to make sure I change the heights in my program a little bit.
Mm-hmm.
And so that probably changed the way it cut. The good news is I checked 20 random carabiners out of different portions of the batch, and I could not find one that was more than 2 thou off of the nominal dimension. If that makes sense. So like
Yeah.
I measured 20, I averaged them, and they worked out to be, I think it was 177 thou wide. And I think there was one that was like 175. Most of them were plus or minus one. So
Yeah.
it's very consistent within this batch, but between batches, it gets a little bit wild.
Yeah. That makes sense.
The other thing that even compounded on my problem, making it worse, because I have a lot of room in these. Basically, as
Mm-hmm.
long as the slot is visually centered, it's fine. And so I do have a
Mm-hmm.
lot of wiggle room. But the other thing that bit me is my my fixture only fits about the bottom half of these, maybe the bottom three quarters.
Mm-hmm.
And these all have a taper to them. And so when I measured them, I designed the fixture for, well, this was the last batch. I designed the fixture for the last batch, which was even wider, but I designed it for the widest part of the carabiner. Then my fixture walls do not go all the way up the carabiner. And so they are on one of the thinner tapered sections, which makes the, what I call it, the relative size of the carabiner even smaller than that. So they have even more wiggle room.
Yeah.
So I ended up with just a huge amount of slop in my fixture.
Now, is it consistent to which side the taper's on?
Yes. So that is one advantage, is they cut them all in the same orientation.
Okay.
And so that they all are tapered the same.
Okay. So if you designed your fixturing knowing which side is up, in theory, if the bottom is tapered, because that's the furthest in from the laser, that'll be the most accurate part of it. Then you can put that to the bottom side, and you should be more accurate in your work holding setup.
Yes. I'm redesigning my fixture now. That's what I spent all day doing. I learned some lessons with the UV resin about how to make it easier to use and easier to clean out afterwards. And so I'm redesigning that fixture. I'm just going to face off the top, quarter of an inch off my fixture and just put it farther down. And I think what I'm going to do is I'm just going to make it the full depth of the carabiner and kind of let the taper center it a little bit. So I'm going to make it tight.
Okay.
And I'm just going to kind of hammer them in a little. And it should
That works.
wedge itself in there. At least that's my theory.
Oh, that'll be good. So you're just going to have to pop them out with you're going to have to create a relief hole that you can pop them out with.
Yes, which I had anyway.
Yeah.
The one of the lessons I learned with the UV resin is that hole will fill with resin, just because it's a low spot and resin will collect there. So I made that a lot bigger and gave myself more access for my pry bar.
Yeah, and could you put it somewhere where you're not going to be? Could you put the resin somewhere where you're not going to be prying?
That's the other thing I did is I moved where I'm putting the resin. I used to put it on the far left and the far right end, and then just like a little spot in the middle. And now I'm doing a long line on either side of the arms.
Yeah.
Which gives me a lot more surface area. And then also I put my little pry holes at the ends. So they are now separated from the resin. They used to be like part of the same pocket, which was a mistake.
Yep. That sounds like you're making good progress. This is the fun part of manufacturing where you get to optimize everything.
Yes. And like something was going to go wrong. Like I'm not surprised that something went wrong with this production. This is the first time I've done anything over, 70 pieces? And going from production of 70 pieces to production of, I'm going to make 1,000 of these. It's a little different ball game, and I'm learning, and I knew that I had stuff to learn.
Yeah, I've been fortunate in that all of my high production runs have been on a lathe, which are a lot easier to hit on tolerance, especially because the more you do it, you can kind of measure things and watch them go out of spec over time as the inserts wear. versus on a mill, there's usually more complex. So it's kind of, you don't know what's going to start going out of wonk first. It's a little harder to track that, at least in my current setup. But I have done one 800 piece order on my machine, and that one went really well.
Okay, that's good. And going back to this quickly here before we move on. The other issue that I was having is as soon as the tool started to get dull, I was left with a big mammoth onion skin underneath here because the feed mill, because it's a very aggressive bull nose. Is that I don't know if that's the good way to explain it. A large radius bull nose, and it's focusing all of its force downward. It would just kind of move the bottom layer of material out of the way.
Are you talking about a high feed?
Yeah, this was a high feed mill. I'm sorry.
Yeah.
So yeah, it would just kind of move. As soon as it started getting dull, it would just kind of push the material down instead of cutting it.
Yeah.
And I think with this next batch, I'll do some experiments, but I have some 5-flute traditional end mills that are designed for stainless and titanium. And I'm thinking those might be a better option because they have sharp corners. I think they will leave me less of that onion skin. Because I have another probably 24 carabiners that I could save, but it'll take me a long time to deburn. Like it would probably be 5 minutes per carabiner.
So listening to that, I have a quick question. You said you moved your resin curing to the long flats.
Yes.
Those are the same long flats where you're doing most of your machining away, correct?
The long flats are, for the most part, fairly well supported because they're not flexible.
No. I mean, like, you're removing the center portion of them.
Yes.
So you're machining through your work holding, and you're only going to have 2 slivers on the sides.
I've always only had resin on the sides.
Oh, okay. Okay, so the bottoms of it are not being held?
Yes. And actually, one advantage of my process is because I'm using a UV cured resin, you have to get light to whatever resin you're trying to cure. If light doesn't get there, resin stays liquid. So when I remove the carabiner, if let's say there's a burr or something on the bottom of these, and by the way, I tumble them before I put them in my fixture to get rid of some of those burrs. But if there is, a chip or something that kicks it up a little bit, UV resin will leak underneath there and then not cure on my fixture. So I can just blow it out with compressed air and it's clean and ready to go.
Oh, that's cool.
So it's a pro and a con, I suppose, because like that extra work holding would be nice, but also it's quick and easy to get out.
Okay. I just wanted to make sure you weren't counting on that bottom surface area to be work holding because you're machining it away.
No, yeah, it's just the sides.
Gotcha. That makes a lot more sense. I was just thinking of it wrong. That's good. I had another point in the back of my head, but I lost it. Hate it when that happens.
The other thing that I filled out this week is these tape measures. And I needed to do a batch for my Patreons this month. Well, no, last month. It's now November. And I think I'm just not going to be able to make it in time for that. I think I'm going to have to do a double prototype of the month batch this month and offer my profuse apologies. Because the way I was holding these just didn't work. And I figured out why. It took me a while to realize the cause of my issue. So these tape measures for you audio listeners are basically how do I describe this? Like a circular tin. Like there is a circular wall going all the way around the outside with a big circular pocket on the inside.
A hollowed out hockey puck.
A hollowed out hockey puck, thank you. The problem is the wall does not go quite all the way around. There is a gap in that wall where you can put your finger in to control the speed of the tape measure. The problem is when you clamp this down, it bends specifically right there at that gap, unless you support it somehow. And even if you're not using too much force, it'll still crinkle there because there's a pretty thin section of unsupported aluminum.
Mm-hmm.
and I scrapped a lot of these. So, and I started redesigning my fixture, and then I hired Harrison to make them.
Yeah. Spoiler alert. I'm going to be making those. So yeah, no, I'm looking forward to it. They're a really uh, crazy design, and I think it's going to be a lot of
Thanks,
fun. Huh?
thanks.
No, I mean that in a good way. Like it's going to be challenging on the work holding side. I totally understand where you're coming at for holding these parts, um, because it's just there's a lot of little features in there, and it's a very thin surface on one side or on the face of it, on the outside of it, when you're done. Plus, you have that little hole there. But I think it's a challenge that we'll be able to tackle, and I got material on the way. So
Nice. The lesson I learned is when you design your work holding, think about how your forces are relative to that little gap. I
mm-hmm.
would say as long as that is like you don't want your clamping forces to go across that gap. You want
Yeah,
them to go either into it or out of it, if that's the right direction.
yeah,
So
mm-hmm. Makes sense.
this is the first thing that I can think of machining where I have just like tried and tried and tried and just not been able to get a good method. Like I don't. This is my first big machining failure, I would say, but
Well,
it's a good lesson learned.
yeah, yeah. We'll see what we can do. I'll try to make you proud on this, and for your Patreons as well, if some of them make it over there.
By the way, if you want to support Design the Everything, patreon.com/design the everything. And occasionally the Patreons buy the things for this podcast,
Mm-hmm.
like microphones and cameras.
Yep, which helps out a ton. So, let's see here. I had a pretty fun day. So we're kind of doing this later in the week, so I can actually talk about a little bit of stuff that's happened this week.
Yeah.
So over the weekend, on Instagram, you saw a post by a guy, and I feel really bad because I'm horrible at names and it's eluding me right now.
And now he listens to the podcast.
Yeah,
So he's
now
going to hear this.
he is. He's gonna. I am so
And
sorry.
I totally
It's been a
remember
long
his name, and I'm testing you.
TMC make.
Yeah.
Yes. Oh man, I wanted to say like TM or TPM, but I was like, it's not TPM. I just got the M and the P backwards in my head. It just didn't sound right. Yeah. And now I'm gonna say it on camera. TPM instead of TMP. TMP makes. He had these little.
TMC.
Huh?
Tango Mike Charlie.
Oh, okay. TMC. Oh my goodness. See, I'm horrible at this kind of name, like especially on camera.
Everybody
Anyways,
go follow him on Instagram to make up for our butchering his name.
yeah, yeah. The four of you following our podcast, go follow him.
Oh, we're like 35 now.
Oh, okay, good. we have a small bus now. So, no, but he had a little spacer that we'd made for him, and so that was fun. It was a fun little connection over Instagram, seeing someone you showing someone that needs help, and then me being able to help them. That was a ton of fun. So glad we were able to do that. And then today I went over and dropped off some parts. And did I show you those photos, or have I? Actually, we just posted them today on Instagram.
I haven't been on Instagram today.
Well, if you go check out our Instagram page, the last post we just did were those aluminum enclosures. And it shows them back from anodized and after we laser engraved them. And they turned out fantastic, if I do say so myself. I am so happy with how those turned out.
Oh, those look awesome.
Yeah. So they're an HMI enclosure, 7 inches by 7.5 inches by about 1.75 inches tall. They have an NPT pipe tap on the bottom. The inside is all hollowed out. It's got 4 number 10 screws around the corners that are socket heads that are perfectly recessed, flush to the surface, and have just the right amount of clearance around the outside edges. And then the center big pocket for the HMI to actually sit in, and then their logo right across the front. And it was just such a joy to design and machine, and I only scrapped one part. So
You
and that
forgot
was
to mention the faux knurling on the back, which
oh
just looks
yeah,
awesome.
it really does. Did you like yeah that knurling on the back? I'm so proud. So that's something that's kind of a spin-off from the guns. So I did that. I first came up with that whenever I was doing the top of one of my personal guns. I saw it on a couple other places and wanted to give it a shot. And then whenever we did this enclosure for this HMI, they wanted to have something on the back to add like grip pads, and I was like, I know just the thing. And the thing that makes it look so good was I did a 1/4 inch ball to do the outer profile to kind of act like a border, and then I did a 1/8 inch ball to actually do the knurling pattern on the inside. And
Do you
so
remember the center to center spacing on those lines?
I want to say it was like point 0.1 um, zero point 0.1 inches, and it was like a depth of like 0.5 or 0.6, something like there. It was at the point where
0.05.
yeah, something like that. It was at a distance where yeah, not 0.5, sorry, 0.05. It was at a distance where the tops of them were still the surfaced face, but they were just about to form the top of the knurl. So it's not because I did one that went a little too deep, and they were prickly, and so I backed off from that just ever so slightly so that they weren't um, too aggressive.
They look
And I
great.
think they turned out great. They feel great. Yeah, I am super happy with how that turned out. So, um, but yeah, no, that was an awesome little project that I would love to do more of that kind of stuff because it was nice because you could set it up and just let the machine run because it's hogging out so much material that it which if I had a nicer more horsepower machine, I probably could have done it done in like a quarter of the time. But um, I think each half of that took less than an hour, or right around an hour.
Oh, that's not bad.
So it wasn't nearly as bad as you would think. The hardest part was chip evacuation because in those deeper pockets, because I only have the 1/8 horsepower pump for my coolant pump versus your quarter horse.
You definitely need to get that coolant ring that I have. It is fantastic.
Oh, really? Makes a big
Yes.
difference.
Yes. I've been going through the process of I've been going through the process of upgrading my coolant system recently. It started when I first put together the quarter horse motor or pump. That helped a lot. But then I added that coolant ring, which is from somebody who I will look up now. And it just the coverage on it and like it adds some velocity to the coolant and just the access is just way better than anything else that I've done before.
Yeah.
It is LMD machining, La Rosa Machine and Design. I think it runs about $200 or so, but I mean it's worth every penny.
Yeah. Yeah.
And
It doesn't interfere with your tool changer?
it does not.
That's good.
And he sells it with a couple different versions of like how you hook the coolant in. And he has one that fits the standard coolant line. He had one that fits my 5/8 inch line or 5/8 ID line. So it was just literally hooking it up to a hose barb. It is it is one screw to mount the thing to your machine.
Oh, okay. Use
It's
like a set screw kind of deal?
No, there is a existing hole up there in the machine, and he
Oh,
just has
really?
a socket head cap screw, and it just pops right in. I
Oh,
think he
that's
actually
awesome.
can put in 2 screws, but I just put in one, and it's been fantastic. Though I
Yeah.
was having chip clogging issues with it, which he even he has a warning on his website. He sent me a message afterwards too, and he was like, "This will fill up with chips if you don't have a filter."
Yeah.
And I went, "Okay, I'll see how bad it is, and then add a filter if I need to." Turns out I needed to add a filter. So I have the parts for a filter on the way right now for a like traditional like one of those whole house style filters. And then also after I ordered that, he sent me a message and was like, for mine, I just have a screen that I put in the bottom of my chip pan, and it's kind of like the Tormach one that's already in there. It's a mesh screen, but it's just
Mm-hmm.
a very nicely built, removable screen he has with a finer mesh. And he
Gotcha.
was like, "Should I sell these?" And I was like, "I will buy one." And so
Yeah.
I have one of those on the in the mail, and then I have the traditional canister type. And so basically,
Yeah.
that the mesh style one will act as a pre filter for the canister one.
Yeah.
Um,
Yeah. I've cleaned out my coolant tank a couple times, and it's amazing how many chips get down in there.
yeah,
Um, and I've already switched out three. I've already switched out my filter 3 times because it's just gotten so clogged that nothing comes out, and then I have to switch it out. So it's doing work.
yeah.
Um, and the nice thing about that is it's only like $2-3 per filter, so they're really cheap.
How long is yours?
It was the smallest one, and I would recommend getting a little bit bigger because it fills up just enough to be a little bit annoying. Um, it was like it's only like, what would that be, like 5-6 inches? So it's pretty
The one
short.
he, the one he recommended is the 20-inch one. So
Yeah,
it's like it's a filter.
yeah. No, this one's a toy filter. It does the job. Um, I bet with a bigger filter we would get less pressure loss, which we need every psi of coolant pressure we can get. But when it's a brand new filter, I only lose about a half a psi if you
Okay.
measure the gauges on either side, because I have a pressure gauge on each side, and I'll watch as the inlet pressure goes up and the outlet pressure goes down as that filter fills up. So
I would say whenever you have a spare $400, buy the quarter horse motor, buy the
yeah.
coolant ring. It's like night and day, especially on small tools, which I always had coolant access issues with before, but this just
Mm.
fixes them.
Yeah. So um so had that. What else did we have? Trying to remember what happened last week.
Any more guns you've been working on?
I gotta pick a gun. I have money set aside to buy my next firearm, and I'm trying to decide what to get. And we did do a little bit of engraving work for a few people. So we have done some engraved work, some laser engraved work on a few guns. Um, but personally, I want to find. So I have an M&P Shield 40 cal Gen 1, and I got it many years ago. Um, it's up on our Instagram. It's the orange gun that I did work on, and it's a good gun. But the problem with that gun, um, for a conceal carry, is if you get a little too eager with the trigger, there's there's a little tab on the back of the trigger guard or the that goes around it, and you can actually pull that trigger into that and actually lock the trigger in the back position where it won't fire until you physically pry the trigger forward. I've done it.
Interesting.
I've done it once or twice, and it's taken away a lot of my confidence in that gun in a high stress scenario where you have even less trigger control than normal. And maybe I just have a hard trigger pull. That's probably part of it, but um, it's a bad design overall. And I'm sure I can buy an aftermarket trigger, or I've even thought about taking a file and filing down the points that are causing it to lock, because I don't think it. I think it's there to like protect like an over pull on your trigger, but the Gen 2s don't even have it. Like they've removed it completely on the Gen 2, so I think it's a non-issue for those. Um, but um, I like it, but I think I want to try a different brand. And doing more and more work on guns has given me a desire to add more to my collection. So it's a dangerous thing.
Yes.
But I'm trying to decide between the Glock 43 or 43X, and the P365 from SIG.
What
So
is the more popular of those two?
probably the 40. Well, I don't know. The SIG P365, I've heard a lot of people really like it.
Or
I'll
even
tell
maybe
you, the Glock 43 is a lot easier to customize. I can tell you that because the Glock stuffed machine's really nice. They're a very square body by nature, so it makes it real easy to hold in a vise and modify. And after doing a little bit of research, the SIG slides are a lot harder, and so they machine a lot. They're a lot tougher to machine. They're a lot. I think they're like a hardened steel versus the Glock stuff, which isn't. So I don't know. I'm up in air trying to decide which one I want to get.
does one of them have a bigger like mod scene?
Probably the Glocks. Probably the Glocks have a bigger mod scene, and I really want to put like um, a hollow sun on the top, like a red dot. Um, I think because we did that, I almost bought one. So we had a local gun shop that wanted us to do an RMR cut for a customer, and then the customer backed out last minute after we'd already done all the work.
Oh, no.
And so the gun shop was a little ticked off, and I was like, "Hey, I'm in the market for this, so I might just not charge you for the work and buy the gun in in the site." And I ended up not doing it because I was still trying to figure out what I wanted, but it made me really want a Glock 43. And the other problem is for a concealed carry situation, my M&P shield is a 40 cal, and I only have six to seven rounds depending on which mag I have in there. And if I go with a 43 or 43X or the P365, I can get between 10 and 15 rounds and go with a 9 mil, and I just feel a lot more comfortable with that over my aim with 6 or 7 rounds. if a situation like that ever arose. So it's that old argument of more rounds or more stopping power, and I would definitely go with more rounds.
That's where I would be. Yeah.
So, but it's exciting. We're still planning on trying to get a couple project guns that we can do a lot of work to. Um, right now, it's more of a funding issue. We got a lot of money tied up in jobs that haven't paid out yet, and so we got to wait for those to kind of pay out before we can start spending more money. Um, but that's just the cash flow side of things. It's tough in your first few years of just um, we get some pretty good jobs, but then you have to go buy all the stuff to do the jobs, and you don't see that extra income for like a month or two till that job's complete. So
It's kind of the opposite problem with Kickstarter. Because like I
yes,
got I got all my money up front
yeah,
with after development and stuff,
yeah,
but now it's going to be another 3 months or whatever until I can get another Kickstarter going.
yeah.
And
You got to stretch that money out. So you have the inverse problem. You start with the big pot, and then you're trying to keep it lasting, and it's real easy in the beginning to burn through it faster. At least historically with Kickstarters and people's nature, human nature, it's easy. It's easy when you have a full tube of toothpaste to put a lot on,
yeah,
versus towards the end of the tube of toothpaste when it starts getting down to that last little bit, and you're trying to squeeze it out. I can go a few more days. I can go out and just squeeze it out. So
which I with this money, so I had spent a lot of it like in this process of going full time. Like I had a whole long list of things that I needed to get for the shop, and like that money goes pretty quick when you're gearing up a shop.
mm-hmm.
And then with the money that I had left over, I was very torn on how I was going to spend that. And the smarter thing, the business school like experience seasoned entrepreneur thing to do would be to like just kind of sit on that money and have a nice little cash Easter egg. Spend it on investment when you need to spend it on investment. Spend it on product development when you need to do that. But instead, I had some debt on like the laser. The laser payments. I got it with the PayPal financing. The laser payments were like $100 a month or something, or less than that. And it was like, well, I know I have a tendency to spend money when it is around. So I'm just going to spend this money up front and just pay off the laser. I owed my graphic designer some money, paid that off, and a few other things on PayPal financing. Because PayPal financing is how I grew Design the Everything. Like I built my business on that PayPal credit line because there's 6-month interest-free financing.
Yeah.
And so I paid all that stuff off, which I still had 6 months. Like I didn't have debt due until like March or April or May of next year. And so it's not costing me anything to keep that around. So it wouldn't have hurt, but it's like, I'm just going to pay this off and constrict my spending that way. Cause I know myself. I know that I'm not good at it, nicely doling that out over time.
Yeah. So you've been having fun with your laser?
I have been. I haven't really been using it for anything too productive. Like it's not being used on products or anything at the moment. But just as a shop tool to have around.
Yeah, they're nice.
Fantastic.
I want to get a CO2 laser after seeing some of the stuff that you've been able to do with it.
I want to get a fiber laser after seeing it. But like the other day, I needed plastic washers, and I didn't have a washers. I stuck some acrylic into my laser. I opened up Lightburn, designed a washer in 30 seconds, and 2 minutes after me going, I need a washer, I had a washer that was exactly the right size. It's kind of like the magic of 3D printing for the first time, except much faster.
Yeah. Now, one thing that you need to look into for Lightburn and for your laser, and this is something that I found out when I was using the local university's laser the other day, is that it goes back to exactly the same thing we were talking about with your carabiners, is the kerf of the cut. Lightburn actually has a way to add kerf to their cuts. I haven't messed with it much, but have you?
I've seen the option there, and I've done nothing because it hasn't mattered for my parts.
Okay, I was wondering about that.
I kind of like it being a center on kerf cut. Because so one of the projects I did with it is I made some bedside tables. I laser cut some bedside tables for me and my wife. And in Fusion, I designed them with a zero allowance in the fit up. And then I just cut it with the, kerf center cut. And, that takes off 5 or 10 thou from both sides of your part. And the joints just fit together magically.
Yeah. Because
I'm not trying to
basically
hold tolerances.
Yeah. It just magically fits together because of the kerf.
Yeah. Built-in
That's
allowances.
Awesome. That's a good way to think about it that I hadn't really thought of before. We tried to run a part that was critical on the school's laser, and it did not come out because we did not have kerf compensation on that laser. We didn't have it turned on or dialed in or anything like that. So we're having to remake them because it's just not going to work.
Remember, my last job was in a laser shop too. So I'm intimately familiar with all these realities of lasers. But
yeah. Well, I was just curious because I hadn't thought about the kerf stuff because on the fiber, we don't really do a lot of cutting. It's all engraving. So the kerf stuff I don't even process that when I'm thinking about that. So it was just a different, I only think about it on, at least I was previously only thinking about it on like the large stuff where I'm cutting, 1/4 inch, 1/2 inch sheet metal.
Yeah.
So on that, the kerf matters a lot. So, I did see your video on coming up with packaging on your laser.
Oh yeah. That video was kind of backed up in the video editing queue. That was probably a month ago.
Yeah. I've watched part of it. I keep getting interrupted every time I start watching it. But I'm really enjoying it because the packaging side of things, I mean, Grimsmo's most popular video was all about foam. Um,
What's it?
I
I
think
know
one
what
of his
video you're
most
talking about.
one of his most popular ones. I don't know if it is his most popular one, but I think it's in the top 10.
That's
And it
funny.
was it was the packaging foam, and so I just enjoyed seeing him come up with. I haven't watched it all, but the parts that I've seen has been good.
Yeah.
So.
And I've learned since then. So I don't know if you got this far in the videos, but one of the problems I was having is when I was doing a engraving on the design or on the packaging, the cardboard, it was too
Mhm.
clean. Like it was engraving down into the cardboard, but it wasn't blackening the surface at all.
Yeah.
And after that, I realized that I can because I my laser has a Z axis,
Hmm.
and I can use that Z axis to defocus the laser a little bit.
Hmm.
And so when I do my engraving, it leaves a blacker mark, and it also engraves faster because there's a bigger spot size.
Yeah. So the thing that we were trying to cut on the school's laser were actually focus sticks for our fiber laser.
Oh, okay.
Um, so, and those are very critical because, we'll either need to be right in focus or plus or minus a couple millimeters to get different colors or different effects on different things. And focus plays a huge part. Now, is that focus on yours? Do you have to manually move it up and down?
No, I have a Z axis, a motorized Z axis.
That's really nice.
It also
On the
has
five
like 16 inches of travel, which I find hilarious. But
in Z?
yes,
Oh my!
it's like my mill.
Wow, that's a
it,
lot.
it's because you can stick like if you're engraving a big box, they want you to be able to
Okay,
put a big box in there, but it's
that's
painfully
fair.
slow. But I have just a huge amount of Z travel.
I want to add a Z axis to our fiber laser. I've seen guys that just put stepper motors to turn that hand wheel at the top, and I'd like to do that. Or you can buy fiber lasers that are more expensive with Z axis integration. Um, Now, one thing I don't think we posted it. Talking about lasers, I'm going to double check. We need to post it. It'll probably be posted. Yeah, we don't have it posted yet. Um, do I have a photo of it so I can give you a sneak peek? No, I don't have a photo of it. Of course I don't. So we did some deep fiber engraving on a couple of gun slides,
Uh-huh.
and we do those challenge coins. And so we've started doing deep engraving on challenge coins, and I think we're going to do an Etsy dump of putting them out there, and they look amazing. And I actually was able to, or we were able to, do some 3D engraving, some test 3D engraving, and it came out pretty good. Where it's not like there's hard lines at your different heights. You actually have like curves and actually like transitions between different heights, and it looks. I want to do more of it. It's I think it's something that fiber lasers are capable of, and I don't see as much people taking advantage of it. They just put in a black and white image and engrave it. And if we can get this process down and get good images, I think it'll set us apart because if you can get the true 3D engraving on the gun side, um, you can do scrolling that looks like it was hand done because it actually tapers. The problem with all the laser scrolling versus your hand scrolling is that a laser will put straight vertical line cuts wherever the scrolling is versus the hand, it's kind of tapered as it does that scrolling, and it gives it kind of a 3D depth to it and makes it look a lot better. And like if you look at an image of them side by side, they don't look too different. But if you actually compare one that's been hand scrolled versus a laser one, there's a major difference between those two. So,
How does that work on the software side, the 3D stuff?
so Lightburn has a way where you can create a height map image. Um, and so if you think of a 3D object, you have your X, Y, and Z. But how do you put a 2D image and make it have that 3D in there? What you do is you have solid white being the top of your part and solid black being the bottom of your part, and those represent depths. And then your grayscale transition is the depths in between. So basically, you convert a 3D image into a height map. Um, I think I have an image
That
of
makes
that.
sense. I'm following.
And um, yeah, let me look this up real quick and show everyone. And so if you get a height map, um, you can convert that, and then when you laser engrave it, it comes out and it looks 3D. And it uses that. Basically, what it does is Lightburn looks at that image, and you say you want to do 200 passes. It'll do 200 passes, and at the very bright stuff, the lighter stuff, it'll only do a couple passes, and then it'll slowly taper down to just doing the darker colors every time it does a pass. And so it just slowly. I mean, it's like 3D printing in reverse.
I was gonna say, do you end up with layer lines if you look close enough?
Maybe I can't see. Um,
Yeah, I'd be curious if you looked at it under a microscope, what it would look like. I assume they would have to be.
okay, here's a good one. So I don't know if you
Okay,
can.
that's your height map.
Yeah. So okay, there. That kind of sideways like that.
Yeah.
You can kind of see. So like the brighter colors are the high points, and as it gets darker, it I don't know
Interesting.
if you can.
Can my laser do that? Can I do that?
Yes, you can. You can do it in
Interesting.
wood. I've seen
Yeah.
people do it in wood. In fact, all the videos I could find online where people actually went over it were in wood with a CO2 laser, and I'm like, I got a fiber laser. It's a little different, so
Same software though.
same software, but it took significantly less passes in wood, and I think they had a little bit more problems. For me, I can just run it at whatever my engraving is and just take multiple passes. But with the wood, you have to be a little more careful. But it can be done. And the one guy that I watched, it looked really cool, except when he took it off the laser, it looked like a burnt piece of charcoal. And he had to go run it in a sink with a scrubber and scrub off
Oh, really?
all the soot and everything. And then it looked really cool when it was done.
Yeah, one of the problems with the CO2 lasers is they leave charred edges everywhere.
Yeah. And so that's basically was the problem, was like he thought he just couldn't get it to work, and then he finally took one of his test pieces and like washed it off and scrubbed it down, and it's like, oh, it looks great. I just didn't clean it.
I wish I had a cheat code for like there's got to be some trick for dealing with those edges. Because like with the bedside tables I mentioned making, it took me like an hour maybe to laser cut 2 out, and then it's just like hours of sanding.
Yeah. Those organics are different than metals. The metal side of stuff, I can have different cut recipes. I can have aggressive cuts that leave black charred edges, and then I can go over with a lighter pass, and it's like eating into the material, but not enough to actually like do a deep cut. It's just like a very, very light skim. It's like a finishing pass with your end mill versus a roughing pass, and it leaves a nice clean surface underneath, and then you're fine. So I don't know if you can do that with a CO2 laser, if you can come behind your cut with a lighter pass, but I mean, if you're cutting all the way through, you can't really do that.
Yeah,
The only thing
I was gonna say I do actually do 2 passes. I do one higher power pass that does most of the cutting, and then I come back around a second time. But that's mostly just to clean up like glue spots and like weird material imperfections where it doesn't cut all the way through the first time.
Yeah. So if you were to do it, the only thing I could think of is if you did like a medium powered pass, a light pass, medium. You took it in steps instead of doing it all in one cut. If you took it in steps and then did a lighter pass in between, that would clean up the edge without burning it or remove that burn char before going to the next layer down. That's the only way I could think of maybe getting that to work, but I don't know.
Well, one thing I can do is improve my air assist air. Right now, I'm just using the built-in little pump they have, and if I hook that up to my air compressor, I can get quite a bit more cutting capacity.
That makes sense.
But to do that, I have to get like a relay and a solenoid, so it's still controlled by the laser and a regulator.
Now, do you have a chiller for that?
Yes.
Okay. Did it come with that, or did you have to buy it separate?
I think in this case I bought it separately. You can buy them together, but I wanted a slightly nicer one than they were offering with this laser.
Okay. Yeah. I was wondering about that because that's one thing I hadn't really thought of when I was looking at the CO2 lasers they have.
It was like $300 or something.
That's not too bad. Yeah. And yours is 100 watt, you said?
Yep.
Yeah. Yeah, that's a nice one. Yeah, we'll end up with a CO2 and a fiber laser at some point. In fact, I was just talking to some, and here's a good question because this is a challenge that I'm thinking about. Um, that company that we did the electrical enclosure for, they have an opportunity for me where all of their front panels, because they do these big electrical boxes for a lot of companies, they're between 3 foot by 2 foot is kind of their average size, but they can go all the way up to 8 foot by 4 foot.
Okay.
And they want the ability they have to hand cut all the holes for all the electronic buttons and switches and displays and all that kind of stuff. They want to see if we could machine out, laser out, router out all the holes, and they're all stainless steel enclosures. And then come behind it with a laser and laser engrave the stuff above the cutouts. And it's something that I don't think I could justify getting a machine just for that. But if I could find enough work and could nail down what machine I would need, then it's something that I could foresee doing.
So I've done this before. We used to work with Stanley, like Stanley Black and Decker, their security division. For I believe they were mostly did work for prisons, or at least we were doing work for them that they were putting in prisons. And they would need big electrical control panels. And it would be like panic button and open cell 1 and open cell 2. Like we made those. And yeah, we just put them in our big fiber laser. We had a couple 60 by 120 lasers, and you just do them all at once and then etch them. And
Okay.
However, those are a different class of machine than
Yes.
we're going to put in. We're talking Kern money.
Yes. And I don't want to get that expensive because I could go to my old job and do it, and they have the right type of machine to do that kind of stuff, but they don't have I don't think they have the desire because it's going to be a lot of hand loading, trying to lay it out, and then making sure that you're going off of the right 0 point, and then you got to get really clean edges. And so, if I could machine it out on like a router table, I feel like I could get cleaner lines. I wouldn't have the scaling issue that's can be an issue, or the splatter that lasers can sometimes do, because all of them are polished stainless fronts, and so any splatter that got anywhere would be an instant problem. So
the other thing, and I've not used these, but I've seen them, is they have handheld laser marking lasers, where it's like kind of like an inverted funnel that you set down on your thing, and it projects like the red preview line, and then you pull the trigger and it cuts the label.
Yeah. I'm not worried about the marking. I can figure out the marking. We have the ability to actually remove the tower that our laser.
Oh, do you?
Yeah. Yeah. So we can. I bet I could figure something out. Yeah, I could design
Magnates.
Something that magnetizes to something or has weights that I could use it. Like I'm not too worried about that side of things. I feel like I could come up with a solution that would work. It's the cutting out of the holes accurately on large parts that I'm struggling to come up with something that's cost effective that would work well.
They have those handheld router things, the Shaper Origins.
Yeah, that's true.
I've never seen anyone cut harder materials. I've seen like aluminum and brass engraving, but I've never seen someone
actually
mill
cut
away
through some
stainless or whatever.
Yeah, and that's still relying on someone to hand do it, and for the price point that they're going to want to reach, I can't be sitting there with an Origin router doing that all day.
Yeah. There are a couple lower cost large format lasers. Um, the company that I got this laser from, Omtech, has a line of like full fledged fiber lasers. And I was
Hmm.
actually kind of looking at one of them. They don't have the prices listed; they just have the monthly payments listed, and they're between
Hmm.
like $600 and $1,200 a month.
Oh, that's not too bad for
It's
how
really
long of a
not.
period?
They don't have it listed.
Okay,
I would
because
like
that
to
makes a big
assume
difference
five
too.
years. I would
Yeah,
assume
5 or 6 years.
5 years, but it might could be
Yeah,
like 10 years.
yeah,
But they have
yeah.
a 4x4 laser, 4x4 fiber that's fully enclosed. It could do steel, it could do titanium. I was looking at that going, that might not
Yeah.
actually be terrible, especially because I can't have a water jet in the shop.
Oh, why can't you?
Um, at least without major modifications. I don't have enough water for it, and I don't have sewage. I have some water, but it's
Oh,
very low pressure, lame volume because it's all coming from our
mhm.
well, which is like 200 feet away.
Ooh, yeah, that's true.
And I think I think you can have them recycle water, or maybe they always recycle waters, but it would take like just forever to fill. It takes me like
I
10 minutes for a 5 gallon bucket.
I
Um,
feel like they recycle, but I could be wrong. I think they do.
well, you also have to drain them, and I know at least
Yeah.
the little cute ones that I don't remember the name of the company. I looked at them at IMTS. It's the one that a couple people have, like fidget things and
Oh,
Yates
the
Precision.
Wazer.
No, not the Wazer. There is a more professional unit. It's kind of like the size of a chest freezer. I think it has like a 18-inch by 18-inch cutting area.
Oh,
Protomax is the
yeah,
name of the laser.
yeah, yeah,
I don't remember the company, but it's the Protomax laser or water jet. Those require constant draining, which implies to me that they require constant filling.
yeah,
And I don't have a sewer or a septic or anything kind of hook up in the shop here.
yeah.
So I think a water jet's out for me. Fidget thing says that he basically just has his drain outside, which I could do, but I don't know. I don't really want to. I don't know where he is. I don't remember if he's in a cold area like we are, but
I feel like it was Colorado, but I don't. I can't. Don't quote me on that. Or
might be
Idaho.
like Virginia or okay. Apparently, we have no idea where he is.
Yeah.
Um,
Sorry, fidget things. We
yeah,
we talked to you, but we don't know where you're at.
but yeah, I don't want like that drain line to freeze up. I don't know. It's worth looking into. My shop is heated now, and
Oh, nice.
um, I have a mini split that's doing all my heating and cooling, and it actually has a mode where it won't let the shop go below 40 degrees. So I am safe from freezing at this point, assuming we have power, which we
That's good.
generally do. Um, but I would be worried about like the drain pipe going outside and slowly backing up and freezing. But a
Yeah.
laser doesn't have those problems. Though you do, the costs of running a laser are not zero
Yeah.
because you need cutting gas plus power. I would need a phase converter because it's three phase.
Mm-hmm.
And suddenly, even if the laser is only $40,000, suddenly you're looking at an extra 10,000 to get it running.
Mm-hmm. Yeah. Yeah. Well, I'll have to think on that for a while. Because I'd like to do it, and it'd give me some whatever machine I came up with would give me some other capabilities that I could use probably in other areas. I'm like a collector of equipment. I like collecting equipment.
A big plasma cutter would be an option, at least for the cutting. I don't know if it would leave like a heat affected zone that would change the color of the stainless,
Yeah, I don't
but a
know.
plasma is a lot cheaper than a laser.
I thought about that too. I was just didn't know how the scaling would look on those because the scaling on those is usually a lot worse.
I don't know. I've always thought of plasmas as like these big ugly things that left a terrible finish, like
They can
the
leave
same
really
as an
nice finish.
oxyacetylene. They do. They can.
Um, I just think it's harder to
Yeah.
get that.
But a 4x8 plasma cutter is like
Nothing.
30K, whereas a
Yeah.
4x8 laser is like 100K. And also
Yeah.
talking about these Omtech ones that, you know,
Yeah.
might be a little bit iffy to begin with.
Yeah. Plus, yeah, I don't know if I have the space for anything like that right now either. That's the other issue.
Well, they had the little 4x4 one, which was a pretty neat, small, compact thingy.
Yeah, that's true. That's not too bad. And that would do everything that I needed to do. So, I think that's all I got for right now.
Um, let's see, tape measures. Talked about carabiners. I have been enjoying the pallet workflow on my machine.
Oh, that's cool.
Running the carabiners, I had two pallets that I was swapping out to do the carabiners, and then I recently bought two more pallets. One of which was the Saunders Machine Works pattern one, uh,
Mm-hmm.
which I always used to think were silly. Like, why would you put a fixture plate pattern on your fixture plate? Well, it turns out it's because you can set them up offline when you're running carabiners, and then put them into your machine when you need to run tape measure parts.
Yep.
And so that was nice. And then I bought another one, which I was going to turn into a tape measure pallet, and then I decided to outsource it.
Yeah. Well, I mean, it's the same idea of why would get a Pearson work holding pallet and then put a vise on top of it.
Yeah, exactly.
Same idea.
I don't know. I've been enjoying the Saunders Machine Work pallet workflow.
Yeah, I've been keeping my vise in there. I haven't really had a need to take it out in a while. But anytime I do have to use the Saunders pallet, it's nice to have. So, and it straightened out my table.
Straightened out your table. Oh, because yeah, you were having like parallelism issues.
Yeah,
The picture plate fixed that.
I put shims under it.
Oh, interesting.
So I took my probe. I think we talked about this a long time ago, but when I got my Tormach and I took a probe and I wrote a program that would just probe it and just kind of do a big grid pattern, and then I took all those measurements and stuck them in an Excel chart, and I had like a zone where like I had like a heat map of the different heights, and then I bought a bunch of brass shims and I stuck them all underneath it, kind of based off my heat map. And I got from plus my lowest point was 3.5 thou from my highest point. And I got it down to about 1 thou, 1/2 thou, something like that. And I would just put it on, bolt it down loosely, measure it, take it out, put in more shims, put it down, and just like I got pretty close with the first time I did it, but it still took a little bit. And I think we talked about this because we talked about facing it, but the big problem was I didn't want to face a portion of the pallet in case I had stuff hanging off either side of it. So I wanted to keep the pallet surface, or not the pallet surface, the Saunders plate flush from one end to the other. That way, if I had anything sticking off one end or the other, I didn't run into issues when it like got into a cavity.
Ledge, yeah.
Yeah.
You've seen a really, really big face mill.
Yeah. Pretty much. So, and I tried all sorts of stuff to fix that, but it hasn't been an issue ever since I've done that. So, and I've learned a lot since then too. So that was back in my early years when I was an inexperienced machinist.
I had felt like a very inexperienced machinist lately.
I still am. I'm sure I still do stuff that would make an older machinist cringe and go, what are you doing?
My problem is I kind of enjoy doing that. Like, I feel like if I'm doing something weird, I'm like, how do I word this? I like to do weird things, and I like to try things that shouldn't work just to see if they shouldn't work. And sometimes it works for me, and sometimes it doesn't. Like the UV resin has been beautiful. I have had basically no problems with that. The only problem I had is I learned that my curing times did not scale up from my small fixtures to my big fixtures. And I used to be able to cure the carabiners in a minute, and now it takes like 20 minutes. If I don't cure them for the full 20 minutes, then they don't stay in there as well. But if you cure them overnight, they stay in there too well. So I learned that lesson
But
the
see-
hard way too.
But see, that's the fun thing about all of this is it is fun to do things the unconventional way because you learn so much more, and there's so many little tricks and things that you can do. Like general wisdom is there for a reason, like it gets you down the road. But there's something about challenging the status quo and trying to come up with all these weird, wacky ideas and seeing if they work. And I love seeing how people come up with these. I mean, Instagram's full of crazy work holding scenarios. And I love it. I love eating up people's fixturing.
Yeah.
And I feel like in the world of Instagram, it's becoming less taboo to do something weird if it works.
Yes. Yep.
But it definitely was. Talking to some of the old machinists that I run to around here that aren't as internet savvy, when I bring up some of the different ways that I've done stuff, they roll their eyes and go, "You're insane. Why would you do that?" And it's like,
Just put everything in a vice.
Yeah, just put everything in a vice. If you want to go palletized, you got to spend $100,000. Like I told one guy that he should get a fixture plate for his machine because he was pulling vices in and out of his machine like every other day, and he was just like, "Fixture plates are dumb. They just don't work. There's so much hassle. Yada yada." He's like, "I tried one back in the '80s, and it's just like, okay, dude, keep putting in vices and tramming them in manually."
I have an idea that I want to try out for a cheap automation system. All right, so what if you had, so I'll put like an air vice or some sort of air actuated vice on my table, control it from the controller, easy peasy. Then I will have a just like whole array of cylinders. And I'm thinking this for my smaller carabiner that I'll do at some point. Here's a Kickstarter that I'm making out of 1-inch rounds. I'll have it all cut and staged with like probably 3 or 4 inch tall, 1-inch diameter rounds. Whole big array of them. Sitting just like in a box on the machine or whatever.
Mm-hmm.
Then what if you 3D printed or otherwise manufactured a cylinder that goes in a tool holder in your ATC on your mill, and basically printed it out of like a TPU material. You had some like fins in there for gripping, and what you did is you just went over the stock that's sitting in that reservoir, and you just like poke down on it, and there's the flexible TPU fingers just kind of grab onto it. You lift it up, you go over, you put it down in the air vice. The air vice grabs it. You just go up in Z to remove the part from the gripper, and then go about your machining.
So on the lathe, that is exactly what the part puller is?
Yes, this is basically where I got the idea. But like that wouldn't be hard to do in the mill.
No, it wouldn't. There's stuff out there like that, but it all usually relies on through spindle coolant.
Yes,
or
we don't have.
Or something else, like it locks onto like when you put it into there, it'll grab onto something on your actual thing, and then you rotate it 90, then rotate it 90 the other ways. I like this idea. I want to make this for you. I want this challenge in my life.
It should be pretty easy. It's basically just it's a tube with some grippers in it. Like,
yeah,
you can even kind of have them spiraled, and so you can like basically treat it like a tapping cycle, where you thread your way on and thread your way off.
Yeah, I'm gonna have to think about this because I really want to make this now. This is scratching all of the right places in my brain, and I want to make one. And I want to get this automated, because if you did it right, you would have a hopper basically on the side of the machine that would feed parts in and put the cylinder in the same position every time. And because the Tormach has so much space on the sides, you can hold a lot more parts if you have them outside of your work envelope, and then you could grab them one at a time and move them into your work. It's similar to how Pearson Work Holding
Yes.
automated their machine. And you can honestly even do a cylinder to the side to do what we're talking about, and not have it be something that goes in the tool changer, and save a tool pocket. But in either scenario, I really like this a lot. I want to do this.
And if you were doing steel parts, you could just have a magnet in a tool holder. Put it
Yeah.
on spring or something to
Mhm.
give you some. Well, oh no, chips. That would be bad.
Yeah, that would.
Magnet chips. No, okay, never mind.
Yeah, no.
Withdrawn.
Yeah. Great idea if you can figure out how to clean the magnet every time and make
Yeah.
sure there's no chips anywhere. But I don't see that happening.
Yeah.
Um,
But yeah, I was thinking some sort of like just round rubber gripper that can, just slide
mhm.
over the parts and
Yeah. Yeah, and honestly, the simplest thing that I can think of would be something where it's got three fingers, like a three-jaw truck, and they're spring tensioned and they're tapered out. And when it goes over it, it just the spring tension holds it on. You can pull it out, and then when you stick it in the vise, the air pressure of it clamping will be enough resistance to pop it out. Um, that's the simplest design.
the other thought I had with this is the vice could be on my rotary, and so then when it's ready to dump the part, it could rotate 90 or 180. But I don't have very
Yeah,
much clearance on that fourth axis. It could
yeah,
dump it somewhere else. But
yeah. In machine automation is a very fun environment that I haven't had an opportunity to play in yet that I really want to.
I it's something I want to start doing more because if I get that Pocket NC Solo,
Mm-hmm.
hopefully next year, I hope, fingers crossed, that is all set up for automation. And
Mm-hmm.
I don't know, I want to have some experience with it first and maybe some ability to pass parts between my machines.
Yeah, yeah, yeah. That's a good point.
Which probably means I end up with those Shunk Vero clamps in my machine, which is probably the only Tormach with a Shunk fixturing system.
Yeah. Oh, well, I don't know. There, Big T's Chop Shop. Have
Yeah,
you
he has
seen
the
him?
robot. Yeah.
He's not using Shunk though, is he? No, he's using those Vero grips. Um, I think it's Versagrip. Versagrip.
Who makes those?
Versagrip.
Oh, okay.
I think that's the company. I think
I was
that's
thinking it was like the fifth axis solution or something, but
no. I believe the company's name is Versagrip. And what they make, and it's actually a pretty cool product. If you haven't heard of it or looked into it, they make a system that integrates with a robot, where the robot goes and grabs the soft jaws that are actually going to go in the vise. They pick up the part with the soft jaws, and then they set the soft jaws with the part installed into a pneumatic vise and hand the soft jaws and the part at the same time in the machine. And the advantage of that is that you can have all these different soft jaws set up, and it can go grab the parts. So you can have one set of soft jaws and it can go grab as many parts, but then it can also leave that set of soft jaws there and grab a different set of soft jaws and grab, like, so you can have an array of part A, an array of part B, an array of part C, and then you could have three sets of jaws, and the robot could go grab any of those jaws and then go grab any of those parts and then put them in the machine. So that's the advantage of the system over like a palletized workload where you have to manually unload and reload the pallets, even though the pallets can be automatically loaded. Or the disadvantage of having a robot load the parts directly into a pre-set up jaw. This combines those two, and so you can change out the work holding and grab the parts with the work holding, if that makes sense. So it's a pretty cool system.
have you seen any cool like automation devices, like air actuated or however else?
Not too many. Um, Trying to think. Everything that I've seen has been based around kind of a palletized workload. I haven't really seen any air actuated jaws or hydraulic or electric, you name it.
There's one company that's just called like Airvice LLC or something like that, and they have a pretty what seems to be a pretty neat solution. I think it's like 1,000 or 1,200 bucks.
Mm-hmm.
Um, there's a bunch of like kind of hacky automation systems. There's a lot of like things that are basically just a Kurt Vise with some sort of actuator. And
Yeah.
they're just too big for the Tormach. There's a guy. It's actually a pretty cool system. There's a guy that has a adapter that you stick onto the end of a Kurt Vise or anything that uses that same standard hex, and it's just basically got an air ratchet in there, and you just feed it air and
Okay.
it closes. But those are also like $2,000,
Yeah. Yeah.
and then I also need a Kurt Vise, so I'm like, I don't know, 3,000 in, 3,500.
Those things are so expensive.
Yeah,
Um,
I don't believe in vices, other than the mod vice.
yeah. Yeah. No, there's a lot of work holding is like an area that there's can be a lot of cool stuff you can do.
Datron has their little vices, but I've heard those are kind of wimpy.
Oh, really?
Yeah,
Well, if they're designed to hold plate work, so they're not really designed to hold like your traditional small part or something like that. I don't feel like they are, at least.
and on fast, high-speed, zippy machines, not a machine where you're taking a big cut with a 3/8 inch end mill. Like,
Yeah, that's the other thing.
yeah,
Your cutting forces are a lot less, made up for with how fast it goes.
yes.
So,
I don't know. I wish someone would make like I wish Saunders would have an air vice or something. That, something that's reasonably good at a reasonable price.
yeah.
Um, like all of his stuff.
Well, that might have to be a product that I come up with or you come up with.
Yeah,
That would be.
I think the challenge is force multiplication because shop air is 120 psi, but clamping forces for a vice is what, a ton, like 2,000 pounds, give or take, depending on your vice. I don't know, maybe 1,000 pounds is fine for most applications. I don't know, but how do you go from 120 to?
Well, I mean, vacuum work holding is only 14 psi.
That's true. But yeah, but it's only really used on parts of the big surface area.
Yeah. I'll have to think about that.
Yeah, I don't know. There's got to be a way.
This has been a very productive talk. It's got me thinking about all sorts of cool ideas.
This may actually be bad for you because you need to focus.
I know I need to focus, but I still haven't found my niche, and these are fun ideas that are easily distracted in my ADD brain.
Dude, I feel that. It's like even these tape measures are really a distraction for me.
Yeah.
Adding to the bad week, I lost that order of 50 tape measures from the guy who wanted to white label them.
Oh no.
Basically, he didn't realize that I was selling them to other people too, and he thought he had exclusive rights to them. It's like, no, sorry, this is what white labeling is. I wasn't just going to sell you the design. That's not how this works. It's my design that I'm selling to multiple people. You were just a customer.
Mm-hmm.
And he was like, oh, that's less cool now. It's like, whatever. I first heard that he was upset because one of his friends sent me an Instagram message. It was like, oh no, I don't know if I want to deal with this guy anymore. He's kind of picky. And then I found out why he was upset, and I was like, okay, whatever. I'm done with you. You have been fired as a customer.
Yeah. Yeah, there's so much work that goes into that stuff that you can't sell that much work for the price that they want to white label it for unless they have a high enough volume. It's like, it's one thing if you if you, and I actually do have someone who's done this with me, and I'm in the middle of working on it. Um, so I might talk about this in a later podcast. But I do have an individual who is wanting us to produce a product for them, come up with everything, and then they're going to sell it. Um, Although we're not really coming up with everything, it's complicated, but it is something that we are not planning on selling, and he's going to be the exclusive rights to it because we're doing it for him. He has a product he wants to bring to market. We're going to be the design and manufacturer of it. And that's different than coming up with your own product and then offering it to people to put their labels on.
Yes. Do you own the IP then, or does he own the IP? You need to make that clear from the beginning.
Yeah, it'll probably be him because I don't think it's anything that we're gonna need the rights to or want the rights to. So plus it's reproducing something that already exists. And it's just going to be a replica because they don't make them anymore. Type deal.
Did he pay you for the design and development time?
He's going to be, yeah. That's all part of it.
Then he owns the rights. At least.
Yeah. I mean, we're quoting with all that stuff in there. So yes.
Yeah. I would put that in the invoice, I guess. So I was gonna say the PO, but you aren't sending the PO. I would put that in the invoice.
Yeah. So and if it works out, it'll be nice because it'll be something on a reoccurring order basis, because it'll be something that if it sells well as he thinks it's going to sell, then it'll be something that he'll place an order for a couple hundred at a time. Very similar to kind of your tape measure idea. Just it's his own product that he came to with us. So.
All right. If you're done, I'm done. You want to take us out?
Yeah. For those of you who held on for our disjointed conversation this evening, we appreciate it. This is Harrison with Precision Ingenuity, and I'm here with AJ from Design the Everything, and we're signing out.